Okay, so now we are in the week 9 of the live sessions. So I'll just the laser. Yeah. So I welcome you to the week 9 of the live sessions of the course Engineering Graphics and Design, conducted by NPTEL. So the course instructors, as you might already know, Professor Dr. Sunil Kali and Professor Dr. Naresh Datla from IIT Madras, IIT Delhi. So introducing myself, I am Vikram Balaji, a research scholar from the Department of Mechanical Engineering at IIT Madras. Okay, so a quick recap of what we learnt in the previous session. So we saw what is CAD, which is computer aided design, which is called CAD, and what is the basic history of its development. So from the early 1960s to till today, what were the path of development of CAD, and we basically mainly saw the 4 stages of progression. So starting from the 2D wireframe, then following to the 3D wireframe, then we came to the 3D surface modeling, and then we came to the 3D solid modeling. So these are the history of development. Later we saw a brief introduction into the Autodesk Inventor software and the environment. So we saw that there are mainly 4 environments in the Autodesk Inventor. One is part modeling, another is assembly, another is drawing, and another is the animation, or which is called as presentation. So we saw some preliminary part modeling commands, like for example extrude, then we saw the fillet command, when the chamfer command, then we saw the hole command. So some small commands like this, and we saw some modeling examples. So this week we will again continue the preliminary part modeling commands. So in the lecture you might have seen about some commands like Loft command, Revolve command, and some commands like pattern. So based on that we will see some examples in this session. So again, Autodesk Inventor. So Autodesk Inventor is a CAD application for 3D mechanical design, simulation, visualization and documentation developed by Autodesk. So as I told, there are 4 main modules or environment. So first is the part modeling, second is the assembly, third is the drawing, and fourth is the presentation. So a brief description of the 4 modules are given. So basically, to model a part in Inventor, we start by drawing some sketches to define feature profiles and paths, and then we use commands to apply the parametric geometry to the sketched geometry and generate 3D part features. So and finally we combine the features to create the parts. So later, to create an assembly, so we insert the components into the assembly or create parts and sub-assemblies inside the assembly file. Then we use some commands to define the relationship, position and degrees of freedom. So another environment is a drawing environment. Drawing environment helps to create detailed part and assembly drawings that include multiple views, annotations and dimensions. Move this screen here. Then Inventor presentation helps to create exploded drawing views or raster images of the model and create animations. So there are some actions like tweak, action, etc. So this we will see when we are dealing with the presentation. So other than the above main modules, we have some modules like sheet metal, mold design module, etc. So this was the brief introduction of Autodesk Inventor. So now going into the session, first we will see some multiple choice questions, and then we will go into some part modeling exercises. Okay. So here are our questions. So I will just shift into pen. Okay, first question is, the given icon is used for which feature? So you can see there is an icon which is over here. So there are 4 options. One is the extrude option, option B is loft option, option C is revolve, option D is sweep. So can anybody say what is the correct answer for this?
Loft command.
Yes, correct. So loft command. So loft command, basically you have 2 profiles which are separated from each other. Suppose we have a circle over here, in the same example, and then we have a square over here. So loft, what it does is, it creates a solid by joining these two profiles in a certain manner like this. So you will get a solid like this. So this is the loft feature. Okay, so now we will go to next question. So the given icon is used for which feature? So for option A is to create identical feature with equal spacing in one direction, to create identical features with unequal spacing between them in two directions, to create identical features with unequal spacing between them in three directions. So main
Sir.
thing, yes,
B.
yes, B, correct. So actually, so when you have a feature like say hole or some pocket or even a solid like this, so let us say that you want to copy this solid in multiple directions. So what this feature is called as pattern. So pattern, you have mainly many examples. So this pattern which is given over here is called as rectangular pattern. So what it does is basically you have a rectangle, right? So rectangle has two directions. One is this direction, another is this direction. So suppose our solid is located over here. So now we want this solid to be moved to this some place on this rectangle. Let us say in this place with a spacing of some 10 mm maybe. And at the same time we need these two to be repeated again in this direction. So this may or may not be 10 mm. So we can give 10 mm also, but let us say we are giving some 5 mm. So you have this one solid. So now we are going to create three more solids. So to create this, we use this command called rectangular pattern. So we give some unequal spacing between them in two directions. So since it's a rectangular pattern, we have two directions. So this is direction 1 and this is direction 2. So along two directions, when you give the required spacing, you will get the pattern which is replicated. So this is the pattern, rectangular pattern command. Okay. So now coming to next question. So the given icon is used for which feature? So to create duplicate feature with equal spacing along a circular curve, to create duplicate feature with equal spacing along a straight line, to create duplicate feature with unequal spacing along circular curve, to create duplicate feature with unequal spacing along a straight line.
Yes, sir.
Yes. Okay. So as you see the picture itself denotes that it's a circular curve. So we have two options which indicates a circular curve. So it is option A and option C. But if you see this feature in Autodesk Inventor, you will see that you are able to give the angle between two. Suppose you have a circle like this and you have a feature which is located over here. So now what this does is, either we can mention the if you want to replicate it multiple times, say like this 1 2 3 4 5 and 6. So now we want one solid which has to be now replicated 5 more times. Totally we get 6 solids. So what we get is, either we can specify the angle and you can specify the number of specimen, or you can just mention the total number of specimen. Either thing is correct. So either you can mention the angle. So if you are mentioning say 60 degree, so it is already known that you are going to replicate it 5 more times, because the total number corresponds to your total angle divided by the angle in between. So 360 by 60 will give you 6. So which means that 1 plus 5 more components are there. Or you can also give the number of components which need to be replicated. So if you give 6, automatically it positions the solids in such a way that the angle between two solids is 60. So it is a equal spacing. So option A is correct answer. Okay. So which tool can be used to create a frustum of a cone? So option A extrude, option B loft, option C revolve, option D extrude or loft, option E loft or revolve, Option F, extrude or revolve. Option G, all. So can anybody say what would be the answer?
Loft command, sir.
Okay, loft
B.
command. Okay, so let us say that we are having a frustum. So frustum of a cone basically means, so this will be your cone. So you have a base and you have a apex. So this is a cone. So when you are cutting this, so this is a right angle cone. So why it means that this will be 90 degree. The axis is at an angle of 90 degree to the base. So that's a right angle cone. So now when we are cutting this cone along a plane like this, so now what we are going to get is, we are going to get what is called as frustum. So we have two circular bases. So one is of a larger diameter, one is of a smaller diameter, and now we have a conical surface in between. So this is called a frustum. Okay. So loft command we can use definitely, because you have, suppose this is a profile 1 and this is profile 2. So you can select two profiles and then you will get a solid which connects both. So that is one option. So extrude and revolve, we can say that extrude it is not possible, because extrude, when you give a particular profile, it gives the extension of that same profile to a particular thing. So we can only draw a cylinder in case of extrude, but we cannot draw a frustum. So what about revolve? So can we develop frustum using revolve command?
Yes, sir.
Yes, because, so let us say that revolve means basically you are going to create a solid by rotating a profile along some axis. So let us say that we are having this as our axis and this is going to be our profile. So we are going to draw like a half trapezium we are going to draw. So like this. So this is my profile. So this will be my half diameter of the larger one, and this will be by half diameter of the smaller piece. So if this, I am going to revolve like this about the axis. Let us say I am going to revolve it for 360 degree. So the resulting solid will be this frustum only. So revolve is also we can do, but loft is easier to do, because all we need is, we need a just two circles and we can create the solid. Here we need to draw this profile in the sketch plane, and then we have to rotate it. But it is also possible to develop the frustum of a cone from revolve. So answer is, will be extrude and revolve, loft and revolve, right? So I think option E should be the answer. So do you agree? Loft and revolve. So through loft also and revolve also I showed how to create the frustum. Is it okay?
Yes, sir.
Yeah, okay. So this is the frustum. So like these questions may come in your assignments also. Okay. Next question is the minimum number of sketches required to use the loft feature. So option
Yes,
A 1, 2, 3, 0. So what's the answer?
B, sir. 2.
Yes,
3.
correct. 3.
Okay, 2.
It's actually
3 is 3.
okay. So just now I explained, right? We have a frustum. So which means that I have a one profile and another profile I have a small profile. So this is just two profiles, two sketches I am having. So I will be able to do the loft, right? Or we cannot able to do. So you will get the loft, right? Or you will not get it. So in this case I'm just getting the frustum by just using the loft command based on two profiles. One is the circle, bottom circle, another is top circle. Correct. So actually 2 is the answer. So 3 also we can do. For example, we want to do some shape like this. So we want now we want some another larger thing. Here is So now I'm going to get the solid like this. So this is for 3, but the minimum number of sketches we can say that the answer is 2. Okay, so hope this clarifies. Okay, so another question, while using the loft feature, the sketches should be in single plane or different plane, or it can be single plane or different plane. So what is the answer?
Different planes, sir. B.
Yes, correct. So just like previous case, we have the frustum, right? So we had 2 circles. So these 2 circles are not in the same plane. So this circle, for example, will be located in this plane, and this circle will be located in this plane. So when the 2 sketches are now separated by some distance, say this is 50 mm. So this will be the height of the frustum. So when we are separating only, we are able to develop the solid. Otherwise, when we draw in the same plane, they will be like a concentric circle. So we cannot loft this thing. So we cannot develop a solid by this case. Okay. So next question, I think this is the last. I think, to specify the angle of a circular arc, how many points are needed to dimension? So option A 1, option B 2, option C 3, option D 4.
Option C, sir.
Yes, 3. So angle also, so circular arc, let us say we are having this arc. So how many points are need to dimension? So we say, let us say we have this point 1 and point 2. So the angle subtended by this arc, obviously with 1 and 2 there can be many cases, but for the case of angle you need another point called 3. Then only you can measure what is the angle subtended. So this 3 will be your center of this arc, you can say. Otherwise, even if any situation, suppose we have some 2 lines which are inclined to each other. So in this case also we need 1, 2 and 3. So we need to select all these 3 points, then only we will get the dimension feature, the angular dimension activate. Otherwise, if you select only 1 and 2, you will get a linear dimension which is activated. Similarly, if you select only 2 and 3, the linear dimension for this will be activated. But if you select 1, 2 and 3 in the same time, you will get the angular dimension which is activated. So we need at least 3 points. How many points are needed? We need 3 points to dimension. Okay. So yes. So we have just looked into some MCQ questions. Now we will start going into the modeling. So I will now go to this one. You can say, yes, Autodesk Inventor Professional. So last time I showed you some things regarding this. So first we have to open the new command, and then we have to open this standard. So this is the part modeling dimension. So these are all sheet metal. So as I told last time, so this DIN gives inches, and this standard holds for the mm. So here we have English, we have metric, and other templates also we have. This is for drawings, this is for assemblies, and this for presentation. So now we are going to part modeling. We'll press create. Okay. So now let me go back to the PowerPoint. So now we have what is called some solid. So we have the front view, top view, and the section view are shown. So let us see how to do this. So first we will start from this base. So this base is of a 7 mm diameter and is of a 3 mm height. So we can draw a 7 mm circle and we can extrude it for 3 mm height. So first we will do that. So I start the sketch in the bottom. This is the XZ plane. Okay. So now I am going to draw a circle. 7 mm dia. Okay, so I will finish the sketch. It is fully constrained, so I'm going to extrude it. So it automatically detects the sketch, so I have to give a 3 mm height. So I get okay. So now I see here I have just generated the solid, but what we are seeing is we are having some hemispherical cutters there. So how to get this hemispherical cut? So can anybody tell what to do? How we are getting this cut? So if you don't know, that is not, it's okay. So what we are going to do is we are going to create some sketch like this, and we are going to revolve it about the axis. So if I draw it here, or else you can draw your full semicircle also, that is not a problem. So when I am going to revolve, I am going to choose the cut operation instead of the addition operation. So in the last time I have told you there is something called as Boolean operations. So in that there is something called cut. So now I am going to start a sketch in the, let us say, XY plane. So that's a vertical plane. Okay, so now we'll see what is the dimension of the cut. It is a dia 3, which means radius is 1.5. So let us say I am going to start a arc. Let us say it's a arc with center point. So select the center. So at so I'm going to select 1.5 and 0 degree, and I'm going to up to 90 degree. I'm going to draw the arc. Now I draw the arc, and now I have to draw a line to close that sketch. So this line, yes. So from here to draw the. So for temporarily, let us say that I am going to make this invisible. So is it possible? Okay. Anyway, we will finish that. So if I make this feature, copy, delete, suppress, edit sketch. So the invisible feature I think is not there. Okay. Anyway, we have drawn the thing. So now we are going to revolve it. So select the profile. I'm going to select sketch 2. Okay, so I have to go again to sketch 2. I have just drawn the line and this arc. I have to complete it. So the bottom line is missing, so that's why it was not detecting. So now from here 1.5. So now sketch is finished. The revolve. Now it has detected the sketch. So you can see that there is a thing. So we'll select the axis. So axis is same as this axis of this cylinder. So let us select this surface. So you can select the y-axis. Yes. So you can see that hemispherical cut is created. So angle is 360 degree. So if I give OK, if I now rotate, you can see that a cut is created. This is the hemispherical cut. So I hope now you understand how the cut is created. You again go to home view we'll see how the rest of the model is now there. So we have created the base and we have created the cut. Now another cylinder is there, so which is of a dia 6 mm and height 4 mm. So I'm going to create a sketch here. Now dia 6. Yes, finish the sketch. Extrude it for 4 mm height. Okay, so we got it. Next, again we have one cylinder. So this is a 4 mm dia, height is 11 mm. So 11 mm, 4 mm dia. So I'll select the sketch once more. Circle, 4 mm dia. I have to extrude it to the height of 11 mm. So I zoom it. So now we have this. Next, so there is also a fillet feature is there. So 1 mm. So now we are going to fillet the. So maybe once we finish this upper aspect, we can do the fillet. So now there is another feature. So it is diameter is 6, height is 7. So I'm going to draw another sketch of diameter 6. Center, diameter 6. Finish, extrude. Let us see what is the height. 7. Okay. So now you have to do the fillet. So this is a R3. So fillet 3 mm. Selection set. Select edges. Yes. So 3 mm. You okay? So now we got this filleted thing. So now you have to do this edge. So let us see what is the dia. It's a 1 mm. Yes. So okay. Again, this also I have to fillet. Again 1 mm. Okay. So now we have finished the solid. So let us see. So we have finished this portion. We have finished this portion. We have finished this portion. We have finished this portion, and cut also we have given. So if you see from the top, you will be able to see it's like this. Set of 2 circles. So this is a bottom view actually. Bottom view. This is a front view, and this is your section view. So from the bottom, if you see, you will be able to see this cut circle and this 7 mm circle. Rest all will be hidden, but they have not shown the hidden. That is okay. So we are able to see the model, the solid. So now I'm going to save this. Let us say now I'm going to select a new folder. I select peak 9. I'm going to select this part 1. So we have done this. So now I'll go to home, here down, I again click new. So before that we will go back to this. Okay, so now there is a we'll see some loft. So have you seen some component like this? So what does it look like? Can anybody tell? So this component, so actually this is nothing but your head of a hammer. So hammer, if you see, this will be your striking portion, and this will be that that bent portion, so which we will get. So here you will attach the handle. So once you attach this handle, so this is the head of that hammer. So this is as I told, striking end, and this is the end where sometimes you can able to pick the nails. So that will be there. So this is like a simplified version. So this simplified version, we will now see how to model it using the loft commands that we are going to do. So the dimensions are not given, so we are going to assume some random dimensions. So anyway, we'll now go to the things. So you can see there is a square is there. So here a circle is there. Again circles are there, and there is some another here some profile is there. So we'll see how slowly we can able to do the product. Again I'm creating a new. Yes. So now I'm again going to new part model. So I start the sketch. Now I'm starting the sketch in this vertical XY plane. I start with a square. So I'm going to do a center point rectangle. So we have to choose the center and give the dimension. I'm giving 60 mm width, 60 mm height. So we'll see what we are getting. So like this, give the finish sketch. So now I'm going to create another section at some offset distance. So first we have to create a plane that is offset from the. So this was we created in the XY plane. So let us say XY. So we have this. So here you can say we are going either this way or this way. So let us go this way, 25 mm. Accept. Start a sketch in this plane. Now I'm going to draw a circle with center at the same point and diameter, let us say 50. So finish the sketch. Again you have to offset the another get another plane by offset. I select this point, again 25 mm, the same direction. So now I'm going to draw a bigger circle. So I'm going to go there. So I hope you guys are also able to follow. So if you also have Inventor opened in your computer, you can also parallelly try this solid with me. So before going, let us say that now I want a circle in such a way that my center should be at this point and my the radius should be up to this point. So first what we are going to do, we are going to project this point. So before projecting, I don't want this to be the part of a sketch. So I just create what is called as construction. Okay, so I select the construction. Now I am going to project geometry and I am going to project this point. So now you create some yellow color line is created. So it is a construction line, construction point which has been projected. So I remove the construction now. So please remember that if you select this once, before going into other sketch, you have to remove it. If you are continuing in construction, no problem. But if you are going to construct the real sketch, then you have to switch this off and come out. So now I am going to select the circle with center point at this and radius touching this point. Okay. So now automatically this circle is also constrained. So now I have created totally 3 profiles. So another profile I am going to create. So I am going to offset from the plane again same 25 mm. So now what I am going to do, I am going to start a sketch in this plane. So now I am just going to copy that circle onto this sketch, onto this plane. So what I am going to do without going into construction. So now I want a real sketch itself. So I am going to just project this circle. Okay, so now if I finish the sketch, I see that automatically the circle has been copied to this profile plane. Okay, so now let us try to do loft for this. So click the loft command. So you have to click to add. So I'm clicking here. So what are all the sections? So this is my first section, this is my second section, this is my third section, this is my fourth section. Okay, so before this I just show some other possibilities. So instead of creating like an order, so let us say this is my first section, this is my second section, and again third section like this, and fourth section like this. So if you do like this, you can see that the solid is somewhat a half facade solid is created. So it's always remember that the order of lofting is very important. So I am going to select the correct order. This is my first, second, this is my third, and this is my fourth. So this is the correct order. Or you can go reverse way also. So from 1, 2, 3, 4 like that also reverse you can go. So I'm going to click OK. Yes, I get this point. So we see, so this head part we have now created, correct. So I'll make this invisible, visibility, visibility, and this also visibility. Okay, so now we are going to create this behind this fork part is there, right? So we are going to create that. So you please follow how we are going to create that. So this is very important. So now I am going to create a plane. So if you see here, this is located in one plane. So we saw that we do the circle, then we had this smaller circle, sorry, this is a square, and then we have the smaller circle, and we had two bigger circles, correct. So we got up to this part. So now here you can see there is a rectangle actually which travels throughout, but this rectangle is not in a same offset, it is actually inclined. So how we are going to get the incline, that we are going to see. So this will actually go and connect like this, this will go and connect like this, so something like that. So this will go and directly connect over here. So you can see, so it's a different kind of thing. Erase these two. Again try to retrace. So like this. So like this. This will go something like this. So then you have a square, sorry, rectangle. It goes like this. So like this we are going to connect this thing. So we'll see now. So first we are going to draw, let us say parallelly, and then we'll see how to make it incline. So I'm going to offset from this plane, this side 200, or let us say I'm going to do 150. Okay, so if I zoom all, you can see that we have created something here. So now what I am going to do, I am going to introduce a new command which is called as angle to plane around an edge. So first we are going to create an edge, construction edge in this plane. So let me go to sketch here. So I'm going to create an edge. So I'll switch on the construction, the line, I'll get some horizontal line randomly. Okay, so this is, so you can see there is a line which I have drawn and now I am going to draw another line in construction mode from this point perpendicular. I am going to draw, like before drawing I am going to dimension this thing. So from this point to this line let us say this vertical distance is about 75. Okay, so now I'm going to draw a construction line from this point in a perpendicular manner. Okay, so now I'm going to make this line symmetric. So how I'm going to do, there is a command here, the point is called a symmetric. So now I'm going to select these 2 points, this point and this point, and they are going to be symmetric about this line. So now automatically you can see the points have changed. So the whole the line edge length has been remained the same, but now the points are adjusted such a way that they are symmetric about this line. Okay, now we have, let us say we finish this sketch. So now what I am going to do, so please you follow carefully. Now I am going to create a plane which is inclined at some angle to this plane and is passing through this edge. So that option is angle to plane around an edge. Okay, so first I am going to select this plane and then I am going to select this edge. Okay, so now if you see, so what it happens is, this is now at an angle of 90 degree to this plane and it is passing through this edge. So any doubt in this? So first I created an edge in this plane, and now I want to create a plane which is at some angle. So let us say it is around 45 degree to this, and it is passing through here, correct? So let us say 45. So I give the tick. So if I go to this view, you can see that this plane is at an angle of 45 degree to this plane and it is passing through the edge. That edge is now falling on this plane. So I hope you now understand how to create basically. So what I have done is, I first created a plane and I created the edge on that plane, and the new plane, how I am going to orient is, it is going to be inclined at an angle of 45 degree to this plane and it passes through the edge. So the option to do that is angle to the plane around edge. So what it does is, it creates an angled work plane around the face or edge. Okay, so this is the thing. So now I am going to sketch in this plane. So yes, so you follow carefully what I am doing. And to sketch, select this plane. Yes, so now I am going to draw a rectangle in this plane. So what I am going to do first, I am going to project the edges. I will switch on the construction, project geometry. I am going to project this line. Okay, so now if you see this yellow color, some line is there, right? So we got this. So now I switch off that and I am going to create a rectangle. So with the center here, I am going to create a length of 150 and height of 5. Yes. So now this sketch is finished. So now you can see that here also I will rotate for you. So now instead of drawing a sketch in this plane, we are drawing a sketch in this plane which is a 45 degree. So when I am going to loft from here to here, you can see that there will be some thing. So some angle will be there. Okay. So I will now I am going to directly give the loft command. So I am going to do some loft. So I select loft, I select this sections, I select this, I select this. So let us say if I give OK, we get this. Okay, so we get this loft from the square to rectangle. But if you see this solid, actually it is some kind of curvature is there. So if I erase it, so you can see that there is a curvature like this. So it's a curve, some kind of a curvature is given. So that's how your hammer, the back part of your hammer head looks actually. But what we have done here is, we have got some straight thing. So now what I am going to do, I am going to reverse this loft command. So now I press the Control Z. Now I have reversed the loft. So now what I'm going to do, I'm going to create an arc. So how I'm going to do is, you will see. So first I'm going to start a sketch in the, let us say I'm going to do in the, this is the plane, YZ plane, correct? So now I am going to have this. So okay, so I have to create a arc, correct? So first let me draw a construction line, switch on the construction, and I start a line. So from this point along the 90-degree direction, let us say I'm going to draw some 100 mm length, and this direction. So it clicks right and okay. So I have got this line. So okay, so this is a construction line. Again I have to now project this edge. So I'm going to, still the construction is on, I'm going to project geometry to project this edge. So now I'm going to remove the construction. Now I'm going to draw an arc, which is I'm going to draw a 3-point arc. So I draw from this point, my second point is this center, and let us say that I'm going to draw an arc like this, some random I'm giving. Okay, so next what I'm going to do is, I'm going to give a tangent. So constraint tangent, why I'm doing is, so I'm going to select this arc, it has to be tangent to this horizontal. Okay, so now tangent, select the first, select second. Okay, so now I have created a arc. So how I created this arc is, I selected this midpoint and selected here a midpoint, and I randomly draw some arc, and then I gave the tangent command to make this like this. Or you can also instead of giving tangent, you can do some, give some radius, and you can draw some arc like that also, but I have used tangent command. So I'm going to finish this sketch. Yes, so now I'm going to do a different kind of a loft. I'm going to loft through this, loft from this surface to this surface, but with this as a center line. So how I'm going to do, we will see. So select sketch, I'm going to select this and this. So this was the previous loft. So additionally what I'm going to do, I'm going to select, there are 3 here, this is rails, this is center line, this is the area loft. So I'm going to select center line, this second option, and I'm going to click to select a sketch. I'm going to select this sketch. Yes, so now I got this kind of loft, and now I click OK. So now you can see that I get the curvature, correct? So now I make this invisible, work plane, this work plane, I make it invisible, and this sketch, which is sketch 5, I make it invisible. Okay, so now we are able to see, we got this hook. So like this, if you want to see, you can see. So from this view it looks like this, from this view it looks like this, and from this view it looks like this. To see right view, you can see that there's a curvature now. This is the front, this is the top. I think somebody's mic is on, so I think you can switch off that. Some sound is coming, I think. Okay, so now we have finished this solid. So now I'm going to save this. So I'm going to save it as part 2. Yes, I'm going to save it. So I think still some voice is coming. So can you switch? Unless you have some doubt, you can please switch off
আমি আর
the
তো
mic.
কলেজ স্কুলে দিতে যাব না। আমি আর স্কুলে দিতেও যাব না, আনতেও যাব না।
Can you switch off your mic? So okay. So we will now go back to our slideshow. So we saw how to create this loft part. So is there any doubt how to do this? So how we created this loft?
It's clear, sir. Can you share the dimensions, sir, to practice it?
Sure. Okay. So first, if I say first sketch, if I go from sketch, so this is a 60 cross 60. So are you noting down? So you can say you can draw a square which is a 60 cross 60. Then after that we have to offset this plane. Next sketch will be 50 mm circle. So it is offset at a 25 mm from the first sketch. So again next, then third sketch, as you can see, it is we projected it as a from center point up to the diagonal of the first square. So that was our radius. We drew the circle. Then we again the same sketch I am going to copy at 25 mm. So I use the project geometry. So from this plane I copied it. So this is my work plane 1, this is my work plane 2. From work plane 2 I copied to work plane 3. So this you can loft it. Secondly, last as I told, this sketch if you see means so this is a some small line which is at a distance of 75 mm from the center. So this is our reference line for tilting the work plane. So that is 75 mm. And finally our another sketch is there, sketch 6 and sketch 7. So if this is sketch 6, if it's an incline, it is 150 mm this thing rectangle of 5 mm height. So that is this sketch. And this sketch 7 is the curve. This curve, how we did this, so we select these 2 points. So this is the center point of the sketch previous rectangle. So this is the center point of the square, and from this point to this point we draw an arc, and then we constrain it tangential to the horizontal line. So that is for this. So like that we are getting this loft. Okay, so we will now go to next thing. So now we have a drawing which is orthographic projection is given. So now we have to draw the model. So we can see that there is a base is there which has 4 holes in it, and that base is of a height 10 mm, and the whole dimensions are given here. And in the central you can see there is a other hollow cylinder kind is there, and you can see there are this portion we discussed this part. So can you say what is this part, this thing which is projecting? Can anybody say what is that name of that part? So does anybody know this part? So it is called as a rib. So last session we discussed, right, this rib, how to do. So we also do we also saw that we have to use parallel rib instead of the normal rib. So that also we saw why we did. So okay, we'll try to model this now. Okay, so I saved it. Now I come back to home, go to new, another part, create. Okay, create the sketch, create this. we will see what is the base. Base is 80 by 80. Draw again rectangle, center 80, 80, 80, 80. Finish the sketch, extrude for how much? I think the height was 10 mm. Yes, it's 10 mm. So already 10 mm is there. Just give OK. Now I'm going to fillet. Fillet is radius of 20. 20 is my first, second, third, fourth. Okay. So now I am going to create the hole. The hole is, you can say, 55 mm. So now we can calculate what is the, so from the center line, from this center line, you can say from the center line to center line is 55, which means that if it is symmetric, what will be this? So it will be 55 by 2. It will be 27.5. This will be 27.5. This will be 27.5. Again, same thing. If I do from this center line to this center line, this will also be 27.5 because it is a square thing, symmetric about both directions. This will also be 27.5. So which means that I am going to draw a hole first, and I am going to mention this dimension 27.5 again from here 27.5. Okay. So hole, I click. So now I just place on this here, diameter 12. Now I give it is going to be a through wall hole. So now I am going to give OK. So now I got the hole. So now I have to dimension this hole. So how to do that? Let us say I go back. Now instead of this thing, I do a sketch. So let us say I have a circle. So hole we don't know how to do, but this we can do. We can give the dimension. So this is from this point to this. Let us say this will be 27.5, and similarly this point to this point 27.5. And this dimension was 12. So now we have got. So now we can say that we can now use the extrude command. So I am going to use the cut operation. I am going to use through all, and now I am going to create the hole. So if you see from top, you see that hole has been created. So now I need to make this feature. So I am going to use a rectangular pattern because in this direction and in this direction, in two directions I want to copy. So I am going to use a rectangular pattern. So this button, so rectangular pattern, if I click, feature is this whole feature. Direction 1 along this edge. I am going to flip the direction, and spacing 55, and direction 2 along this edge I am going to select. So no flipping needed, correct direction, again spacing 55. So you can see that 1, 2, 3, 4. 4 holes are created. I give OK. So I got the 4 holes now. So we don't need to need every time same hole we need to. Just copy. So now I am going to create this cylindrical feature, 40 mm height, dia 34. Cylinder, I have to start sketch. Dia 34. Go to extrude 40. Now I am going to create a hole. So here no problem, because we not position we can directly get from making the concentric. So we got a concentric. Now you get a through all hole. What is the dia? 18. So it is a through all hole. You can see that from this edge to this surface the hole is created. Eraser. So it's a dia 18. Dia 18, and you can see 18. Yes. So now that has created. If you see from the top, you are able to see this is through the material. So now last step we have one more component called rib. So rib, you can see some dimension is there from this point to this point 37 and 4. So we are going to go along across that. So now I am going to create a sketch. I am going to sketch it in XY plane. So now I am going to draw a line from here to here. So now I have to give dimension from this point to this edge. It is 37. So I have to from this point I have to give 4 mm. So I will just create a point, construction point I will create at this point. So now I give the dimension from select this point, this edge 4 mm. Okay. So now it is constrained. So now I exit the sketch. So I am going to create a rib. My profile is this is normal to sketch, this is parallel. So if to select parallel, profile is this. So my thickness 5. Okay. So I get this, I select this, I am getting the thing. Now I just click OK. So I got the rib. So now I want to make 3 more such ribs. So 1 rib created. So 2, 3, 4. How to do that? Now we are going to do what is called a circular pattern. So circular pattern. So the feature, the rib feature, axis will be this central axis. So if you see 4, you can see that some ribs are being created. So what, there are 2 options here. So this is base, this is fixed, this is your rotational. So rotational means along with the angle, the orientation also. So but if you are doing like this, you can say that at the same orientation 4 more are being placed in a circular pattern, but we want a rotational pattern, so we click OK. So now you got the solid. You see from this angle, you see from this angle, you see from here, so it's all the same. So yes, so finally we got the solid. So I don't think any more is remaining. So the ribs we created, the holes we created the cylinders, and we created a base. So this is done. So one last part is there. We will see how to create this part. So this will be the last part for this session. So we'll try to create it quickly. So first let me save this. Part 3. So one more part we are going to do. So what we are learnt is, today we are learning the Loft command, then the pattern command, and then we also first learn the Revolve command for the hole, for the hemispherical cut in the first part. So now I go to home, I create the new standard create. So now to start this, I am going to start from this point, base. So this first I am going to draw a circle of R125, the outermost circle. R125 means dia 250. Finish the sketch. Yes, this height is 15 mm. I'm going to extrude it for 15 mm. Got that. So now we are going to create this kind of a circular slot we are going to create. So if you see this, if we complete it, it's a circle. Again erase it, and it's not coming properly. Okay. So you see circle, and this point, center of the circle, it lies on a circle which has a 240. So you have to draw first a construction sketch on this. So I switch on the construction, I draw a circle, diameter 240. Okay. So next I am going to draw another circle which is 40 mm radius, which is 80 dia. So I am randomly going to, I switch off this, I am going to draw a circle on this randomly at any point on this thing, 80 dia. Yes, but we need to constrain the thing. So now we need to give the dimension, right, of this thing. So how much it is at a 36 degree from the horizontal. 36 degree means, so for angle means we need a 3 point. First point, second point, third point I am not able to select. So first I am going to project construction. I am going to project this project geometry. I switch on the construction, so it is like a construction. So like this we get. Again switch off the construction. Now let us see, I am getting something. So now dimension, first point, second point. Again I am not getting, so I need to place a point, construction point on this.